Now that the quadcopter is basically like assembled, the next thing to do is to set up the flight controller to finish the configuration so that it can like work. And in order to do that, you're going to need two pieces of software. The first one is Betaflight configurator. Betaflight, think of it like, you know how you have a phone and your phone is either running like Android or it's running iOS. Or maybe you have a laptop and it's running Windows or it's running Mac OS. Think about Betaflight like Windows, Mac OS, Android, iOS. The flight controller is the hardware, and that's like your phone. And then Betaflight is the operating system that like makes it all work. And then what are the apps? I don't know. There aren't really any apps. Anyway, the analogy has gone far enough. In order to configure Betaflight, we're going to use Betaflight configurator. And the other thing is that the ESC that we've got also needs a piece of software to configure it. And that piece of software is called BLHeliSuite. I have another video that I made showing you how to download and install these two apps. And rather than just repeat all that stuff, I'm going to link you to that video down in the video description. There's a link to that video. If you've never installed Betaflight and BLHeliSuite before, you're going to need to pause this video, go down to the video description, click away, watch that video, download and install these apps, and then come on back here and we'll proceed. Some of you might already have this installed because this isn't your first build, in which case you're already ready to go. Well, okay, now you're back and Betaflight and BLHeliSuite are installed on your computer. We're going to take a USB cable and we're going to plug it into the USB on the flight controller. When we do that, the flight controller will light up and you should also see your receiver light up. It's very convenient that this flight controller powers up the receiver when we plug in USB because it's going to make it easier to configure all this stuff. You should also see here in the upper right-hand corner of Betaflight, there's this pull-down menu that lets you select the serial port that the flight controller is plugged into. And at least on a Windows machine, and I think also on Mac OS and Linux, when you plug in, you will see a new serial port appear. So there was only COM1, and now there's also COM3. Regardless, you're going to want to select the COM port that appears when you plug in, and then you're going to hit connect. Now here in the upper left-hand corner of the configurator, you can see the firmware version that is running on our flight controller, Betaflight 4.1.6. And 4.1.6 is fine, but we're going to update to the latest and greatest. Betaflight released version 4.2 just a few weeks ago at the time of this release, and we should be on the latest and greatest, right? So the first thing we're going to do is we're going to make a note of this target name, Xylo F4. It's really important that you remember this when you flash a flight controller. The next thing we're going to do is we're going to go to the CLI tab here on the left side, and we're going to back up the configuration of the flight controller. And I got to be honest with you, this flight controller is fresh out of the box. It doesn't have any configuration to back up. I'm only walking you through this step because someday you're going to be upgrading a flight controller that you've actually worked on. And I want you to learn that backing up a flight controller is an essential step of updating. Because when you update the flight controller, your configuration may be lost. And if you have a backup, then that's no big deal. So we're going to go to the CLI tab. And then we're going to type the word diff, D-I-F-F, space A-L-L, diff all. And we're going to hit enter. And some text is going to appear on screen. And then we're going to go down to the lower right-hand corner of the screen where there's a button, Save to File. And we're just going to save that to a file somewhere on the computer. We can name it, name it what configuration, what quadcopter it's from, something that'll help you remember what it is. We're going to save that to a text file, and now we've got our configuration backed up. After you've saved that file, you're going to go up and hit the disconnect button, and then you're going to go over here on the left to the firmware flasher tab. In this pull-down menu, you're now going to scroll down and select the Xylo F4 target. It's very, very important that you select the correct target name when you flash your flight controller, and if you don't know what that is, do not proceed. You can go to the command line or you can connect to the flight controller and look just like we did. We're going to select Xylo F4 and we're going to select firmware version, the latest available at this time, that is 4.2.0. And then finally, we're going to enable full chip erase. Whenever you update the firmware, it's a good idea to do full chip erase. Sometimes it's not necessary, but it will never hurt, especially if you just backed up your configuration like I just showed you how to do. Finally, we're going to hit load firmware and then flash firmware. Now, when you hit that flash firmware button, one of two things is going to happen. If everything works correctly, here in the upper right-hand corner of the screen, this will change from the COM port to the word DFU, and DFU means that the flight controller is able to be flashed. Then you'll see erasing and flashing, which you see down here, and that is what happens when everything works. Now, hopefully for most of you guys, everything I've described so far has worked exactly as I've described it. If anything has gone wrong, like you plugged in the USB port and you didn't see a new serial port, or you couldn't connect to the serial port, or when you went to flash, it didn't flash. There may be a problem with your drivers. You may need to reinstall drivers if you're on Windows. If you're on Mac OS or Linux, you don't need to install drivers. There may be a problem with your USB cable. Some USB cables are charge only. They're not used for data. Like if it came with your phone, it may be charge only. Try a different USB cable. There are various things you can try to do to get it sorted, but hopefully it's worked to this point, and we're going to proceed. Here in this pull-down menu, DFU has gone away and COM3 is back. We're going to hit connect, and Betaflight is going to ask us whether we want to apply custom defaults. The short version of the story is you should always say yes to this. Just say apply custom defaults. Well, then why doesn't it just do it for you? Just hit apply custom defaults button. Having done that, we're going to hit connect again. We're going to get another warning that the accelerometer is enabled, but it's not calibrated. So we're going to close that window, and right here in the setup tab, you're going to set the quadcopter down on a flat and level surface, and then you're going to hit the calibrate accelerometer button and wait for that to finish. Now, typically you'll only have to do this once. Sometimes after like a hard crash or a smack, the accelerometer will get out of calibration and you may need to calibrate it again, but this is not something that you need to do like every time you fly. The next thing I want you to do is go to the configuration tab and follow along with some basic setup that we're going to do here. I want to do something a little different in this tutorial. A lot of times when I do these tutorials, I'll go really deep in depth about why we're making the changes we're making, and it can be a little overwhelming for people. Maybe some people love it. Some people find it a little overwhelming. For this one, I kind of just want to walk you through the changes without going super in depth into the background about why the changes are being made, and get you sort of through this experience and enjoying actually flying the quadcopter as fast as possible. So just follow along with me here. So the first thing I want you to do is over here in the system configuration section, I want you to change the PID loop frequency from 8K to 4K. Up in the upper right, I want you to enable bidirectional D-shot. And then here in the arming section, I want you to change the maximum arm angle from 25 degrees to 180 degrees. I need to tell you what that's doing because it is disabling a small safety feature. And if I'm going to encourage you to drive without your seatbelt, you should at least know what you're doing. The maximum arming angle prevents the quadcopter from arming when it is not flat and level. And the idea is that if you are carrying the quadcopter in your hand with the battery plugged in, which you should not do, and then you accidentally flip the arming switch and the quadcopter would arm, well, it'll prevent it from arming and maybe save you from getting cut or injured. The problem with this setting is that if you're ever trying to take off on a hill, or your quadcopter isn't quite level, or you crashed and it's upside down or something and you won't be able to get back into the air. Setting this max arm angle to 180 disables the maximum arming angle. I do this on all of my quadcopters, and I take other precautions to prevent myself from accidentally arming the quad when I didn't mean to and getting hurt. I would suggest that you do the same, but know that you're disabling a safety feature, and make sure that you take other safety precautions so the quadcopter doesn't hurt you if you choose to do this. Back over here on the left side, I want you to scroll down and I want you to enable the telemetry feature, and I want you to enable the RX set and RX lost D-shot beacon configuration. We don't have a buzzer on this quad. And a buzzer is very helpful if you crash your quad in the grass and you can't find it. So this will allow the motors to beep. The motors are capable of beeping, kind of like a beeper. And it's a good alternative if you don't have a buzzer on the quad. We're going to be doing save and reboot a lot. And each time we do, the quadcopter will disconnect from the computer and we'll need to go back and hit connect. So here's a little tip. Enable the auto connect button and it will automatically reconnect when it reboots. The other thing I want you to do is hit this gear icon, and I want you to permanently enable expert mode. I also suggest that you choose reopen last tab on connect, which will reconnect to the last tab that we were on, right back where we left off. Finally, if you prefer dark mode, you can turn dark mode on. A lot of people are liking dark mode apps these days. You have the choice. What does auto do? Put it in dark mode if it's like nighttime? I don't know about that. Let's just, there we go, dark mode. Okay, I'm going to reconnect. And when I reconnect, I'll be right back here in the ports tab because I enabled that reconnect to same tab option, and I can just double check that all those changes that I made are still made. And yep, they're all still there. The next thing we're going to do is we're going to go to the ports tab and we're going to configure the ports on this flight controller. The serial receiver is pre-configured on UART1. That's the default for this flight controller. Let's find out if that's correct. We're going to go to the configuration tab and we need to tell the flight controller what type of receiver we have. If we have an RXSR, like I do, then the receiver protocol is going to be SBus. And we're going to change that and hit save and reboot. And it will automatically reconnect, and we can just double check that SBus is set as our serial receiver protocol, assuming you're using a FreeSky receiver like I am. The next thing I want to do is go to the receiver tab and we can verify whether our receiver is working. Now at the moment our receiver is not working, and the reason is that our controller is turned off. So let's grab our controller. Let's set this quadcopter to the side for a minute. Let's grab our controller and let's just power that on.
Welcome to OpenTX.
Thank you. And when we do that, perfect. And when we do that, we should see now that these channels they've changed. And as I move the sticks up and down, left and right, we see the channels moving. But there's a problem. The problem is that our channel mapping is not correct. So this is the throttle right here on the left, but the roll channel is moving. And the way we fix that is by rearranging the AETR letters in the channel map. Fortunately, there is a default setting that usually will work. Hang on. Let's choose the Spectrum Grotner JR preset. That doesn't seem right. Oh, it is. Throttle, yaw, pitch, and roll. Perfect. So now we've got our receiver working and our channel map is correct. This is fantastic. We're making great progress. The next thing we need to do is adjust the endpoints of our controller. So I want you to see that when I put the throttle stick all the way down, this channel goes to the value of 987, and when I put it all the way up, it goes to 2011. Betaflight wants those values to be 1000 and 2000, and here's how we're going to fix that. So what I'm going to do is press the menu button on the radio and then press page until I get to the outputs screen. The next thing I want you to do is look right here where my radio reads 988 US, 988 microseconds. And notice that when I move the throttle up and down, that value moves. So that tells me I am adjusting the throttle channel. If I move the jog wheel down and highlight channel 2, then which channel is that? I'm going to keep moving the sticks. Aha, so that is the roll channel. I'm moving left and right. So what I want to do is I want to highlight a channel, channel 1. I want to move the sticks until I see that value move, and then I know which channel I'm adjusting. And then I'm going to put that channel all the way down. I'm going to click the jog wheel once and click edit. Now you can see I've still got that value here in the upper right hand corner of the screen, 988 US. I'm going to go down to the min, and I'm going to click the jog wheel one time. And I'm going to move the scroll wheel to bring that value up to 1000 US, 1000 microseconds. It's not a U, it's a Greek, it's a micro, but anyway, US, that's fine. So now I've got 1000 microseconds there. And also you can see here on the screen in Betaflight, I have 1000 as my value. So I'm going to click the jog wheel one time. I'm going to put that stick all the way in the up position, and I see 2012 microseconds. I'm going to go down to max. I'm going to click the jog wheel one time, and I'm going to roll that until I get to 2000 microseconds. Perfect. And again, in Betaflight, I see the throttle channel is at 2000 microseconds. Now I'm going to press exit one time, and then one time again to back out to the output screen. And I'm going to repeat that process for channel 2, 3, and 4. So I'll do it one more time for you, but then I think you'll probably have it. I'm going to go down to channel 2. I'm going to click the jog wheel one time and click edit. I'm going to move the sticks to try and figure out which channel 2 is. Oh, there we go. It's the roll channel. And in this case, since the roll stick is spring-loaded, I'm going to have to hold this all the way to the left. And I'm going to go down to min. Click the jog wheel and roll the scroll wheel until I get to 1,000. 1,000. I'm going to hold it all the way to the right. Go down to max. And roll the jog wheel until I get to 2,000. Okay. Perfect. Now, for the throttle channel, the throttle is not spring-loaded, so there's no center to the throttle really. But for the spring-loaded sticks, we also need to adjust the center, and the center needs to be 1,500. Now, the good news here is that if we look, we can see that all these channels are already at 1,500, so the centers are already correct. But if the centers were not correct, here's how you would change it. Leaving the stick in the center, which it is, you would go up to the sub trim setting. You would click the jog wheel and you would adjust the sub trim left or right to make the center be 1,500. Boom. Okay. Exit and exit one more time. Now I'm going to repeat that for channels 3 and 4 to finish setting the endpoints. When I've finished, here's what my screen looks like, and I can verify that everything is correct by moving the sticks down, and I see 1,000 and 2,000. Left, 1,000 and 2,000 right. 1,000 and 2,000 and, oh, 998. Oh no, 998. Well, to tell you the truth, it probably doesn't matter, but let's fix it. There's another change that I'd like you to make while we're here. I'd like you to change your stick low threshold from 1050 to 1010 and your stick high threshold from 1900 to 1990. These values are set conservatively by the flight controller developers because they know that people might not have set their endpoints correctly like we just did. Once your endpoints are set correctly, you get a little bit better. It's better to just set these endpoints like I show you here. And then in the lower right hand corner of the screen, we're going to hit save. The next thing we're going to do is set up what are called aux modes or auxiliary modes, but everybody just says aux modes. And aux modes let you flip switches on your controller and tell your quadcopter to do things. Like the most basic thing is to arm and disarm the quadcopter when you want to fly. But aux modes are also used for other functions like making the quadcopter beep so you can find it if you've like crashed in the tall grass, like switching between acro mode and auto level mode and other things that we're going to talk about. Let's set up the aux modes. In order to set up the aux modes, we're going to go to the modes tab. And the first mode we're going to set up is the arming mode, which lets you like arm and like putting the key in the ignition of your car and starting and stopping your car. And the first thing we have to decide is which of these switches on the controller we're going to use to arm and disarm the quadcopter. And one of the things that's both frustrating and liberating about this type of controller is that the switches are not predefined in any way. You can set the switches up to do anything you want, but also they're not set up from the factory to do anything at all. So I like to use this 2-position switch on the left shoulder to arm and disarm the quadcopter. It's really easy to get at. When you're flying, you can, so it's a 2-position switch, arm, disarm. So let's just decide that that's what we're going to do. The next thing I'm going to do is press the menu key and then page to the mixer screen. And on the mixer screen, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8. All of these are channels that can be assigned to one or more of these switches. Now you'll see that the first 4 channels are already assigned to our 4 main controls, the control sticks. And if we look in the Betaflight receiver tab, you can see the same thing. Here's the 4 main controls, and then the 5th, 6th, 7th, 8th, and so on channel are your aux channels. So we're going to make one of these aux channels control the arming aux mode. And the way we're going to do that is we're going to roll the jog wheel down to highlight channel 5. Why channel 5? Well, it's just the first empty channel that's not being used for anything else. We're going to click the jog wheel one time, and that is going to create a new mixer on channel 5. And a mixer is what tells the controller this switch controls this aux channel. Well, which switch? The switch is set in the source parameter. So we're going to scroll down and highlight source and click the jog wheel one time until the source is flashing. And then we're just going to move that switch. And when we move that switch, it will automatically pick up which switch we want to be the source for this mix. And that is all you have to do. There are more things here that we could set up if we were making a more complex mix, but this is the very basic way to assign a switch to a channel. That's all you have to do. So then we're going to hit exit one time. We've got switch SD as the source of the mix. We're going to hit exit one more time, and then one more time again to get back to the mixer screen. And what you should now see is that when I move this switch, aux1 is moving between low and high position. Now that we have assigned the switch to the aux channel, we then set up the aux mode. So let's go back to the modes tab. Under the arm mode, we're going to hit add range. And then we need to tell Betaflight which aux channel is going to control this mode. And if we just leave this set to auto and then flip the switch, Betaflight will pick up which channel is moving and automatically assign that to aux1. Now the last thing we need to do is we need to tell Betaflight which switch position we want to activate the mode. So in other words, should the quadcopter be armed when I push the switch away or when I pull the switch towards myself? And notice that as I do that, this little yellow tick mark moves to show the current channel position as I move the switch. Well, it's really up to you, but personally the way I like to do it is to pull the switch towards me to disarm the quad and push the switch away from me to arm the quad. And I have reasons for doing that, but they're personal and you may disagree. You may feel you want it the other way. But I'm going to put the switch into the armed position, which for me is going to be pushed away. And then I'm going to drag this slider over so it is on top of the little yellow tick mark and hit save. And when I do that, the arm mode will turn red and say disabled. The quadcopter will refuse to arm itself when you're plugged into USB, and so it's disabled for now. But so now when I move it, it's disarmed and armed. Now I'm going to disable hide unused modes because I want to see all the other aux modes. We're going to set some of them up as well. Now you may not realize it, but we've actually created a real problem for ourselves. Imagine a scenario where you've just finished flying, you landed your quad, you go over, you pick up your quadcopter, and then with your transmitter dangling around your neck, you accidentally hit the arming switch. And you have forgotten to unplug your battery, and your quadcopter arms and spins the motors and chops up your hand, and this happens way more often than a lot of people would like to admit. Here's how we're going to prevent that from happening. We're going to set up what's called a pre-arm mode. And a pre-arm mode is like a safety for your arming switch. We're going to scroll down here on the left until we find the pre-arm mode. Here it is. And we're going to hit add range. And we're going to add another mixer. So hit menu, page, page, page to the mixer. We're going to scroll down and we'll just use channel 6 because it's the next empty channel. We're going to click the jog wheel one time to make a new mix. We're going to highlight source and hit enter or hit the jog wheel so source is blinking. And then I want you to move this to this momentary switch, this spring-loaded momentary switch on the right-hand side. Okay, switch SE is the source. And we're going to hit exit and exit and exit one more time to get back to the mixer screen. Now, you'll notice that when I hit that switch and aux channel moved, it automatically filled in aux2 here, and I can verify that when I move that switch, I can see that little yellow tick mark moving, showing that the channel is being picked up and moving. What I'm going to do is I'm going to pull that switch into the sort of activated position, and then I'm going to move this yellow range so that it covers that tick mark and hit save. And then what you'll see is that when I pull that switch, the pre-arm mode activates, and when I release the switch, the pre-arm mode deactivates. Disactivates a word? Sure it is. Now, check out how this works. I'm just going to enable hide unused modes here so we only see the arm and pre-arm modes. At this point, if I go to flip the arm mode, the quadcopter will not arm because the pre-arm mode has to be activated first. So in order to arm the quad, I pull and hold the momentary switch, and then I flip the arm mode, and then the quadcopter still won't arm because it's plugged into USB. But in the field, that's how it's going to work. To arm the quad, you'll pull the pre-arm switch and then flip the arm mode. And then release the pre-arm switch and go fly. And then when you're done flying, disarm by pulling the switch towards you, and now you're disarmed. But if you ever accidentally just flip this arm switch, nothing will happen unless you're holding the pre-arm switch first. There's a few other things you're probably going to want to set up. You're probably going to want to fly this quadcopter in angle mode. Most, if not all, freestyle and racing pilots fly in acro mode, but auto level or angle mode is easier to learn in. So let's set up angle mode. We're going to hit add range. And what I like to do is put angle mode on this switch on the upper right hand corner. You don't have to. Some people like this switch on the left, this great big one, but I like this right hand switch here. So we're going to go down to channel 7, which is our next unused channel. Click one time, source, click one time till source is flashing, move that switch, and click the jog wheel to stop it flash. Oh, I changed it. It was SC, but I accidentally rolled the wheel and moved it to SD. That's my mistake. Let's just move that again. And we got SC, and hit exit to get to the mixer screen. Now here's how I like to set up angle mode. I like to have nothing be when the switch is in the up position. That's going to be acro mode for when you get feeling a little more adventuresome. I'm going to put the switch in the middle position, and that'll be angle mode. And oh look, that's right where the yellow range already is. And so I'm going to hit save, and now angle mode is active, inactive. There's two more modes I want you to set up. The next one is what's called turtle mode, or flip over after crash mode. What this mode does is if you crash and you're upside down, you activate flip crash mode, and then you move your sticks, and flip crash mode reverses your props to cause the quadcopter to flip itself over when it's upside down. This is a little bit more of an advanced move. It saves you from having to walk, and I set this up on all my quads. You may want to learn a little bit more about quads before you start using it, but I'm going to walk you through the process of setting up because I set it up on all my quads. What I want you to do is, we've actually going to reuse this switch. This is a 3-position switch, but we've only used 2 of the 3 positions. So the up position is going to be acro mode, the middle position is going to be angle mode, and the bottom position can be flip crash mode. So what I'm going to do is I'm going to set this, oh, it's already picked it up. Isn't that nice? See, it's already picked up aux 3 because I was moving the switch. So I'm going to put that in the down position and move this over to cover the little yellow tick mark and hit save. And again, if I scroll to the top and hide unused modes, you can see that the middle position is angle mode, the bottom position is flip crash or turtle mode, and the up position is no mode at all. One more mode I want you to add, and that is a buzzer mode. And I'm going to scroll down till I find buzzer or beeper. I can't remember which they call it. There we go. Beeper mode, add range. And what I want you to do, you don't have to set up a new mix. What I want you to do is just move that switch, the pre-arm switch. And we're going to pull the pre-arm switch towards us. We're going to move this over so the yellow range covers the tick mark, and save. And this is what your modes tab should look like when you're done. Double check your work and see if yours is the same as mine. You may be a little confused that we use the same switch for beeper and pre-arm, and it's okay to do that as long as you know what you're doing. When I pull this switch, the beeper will go beep, 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 and when I pull this switch, the pre-arm mode will become active and I can arm the quad. Those two things can happen at the same time. That's okay. And in fact, it's kind of nice that when I pull the switch to pre-arm, the quad goes beep, 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 beep. Oh, you're about to arm. Are you sure? I don't know. So yeah, if you ever lose your quad, or you can't find it, you've crashed, just pull the beeper mode. It'll beep and you can walk right to it. Now, if you set your radio up exactly how I set mine up, and specifically with the disarm switch pulled towards you, there's another change that you're going to want to make. Most radios default to the assumption that all the switches will be pushed away from the user and that's the sort of neutral position. But that's not how I like to do my arm switch. I like to have my arm switch pulled towards so I can kind of rest. Anyway, that's how I like to do it. And if you did it that way, you need to let the radio know that you've made that change, because here's my switch in the disarm position pulled towards me, and when I turn the radio on,
Switch warning.
so when I turn the radio on, it's going to give me a warning that the switch is in an unexpected position. And what I'm going to do is this. I'm going to hit exit, and then I'm going to hit menu, page, and I'm going to scroll down to the section in the menu where it says S-warning, switch warning. I'm going to put all my switches in their default position. So all the switches are going to be pushed away from me, except for the arm switch, which is pulled towards me into the disarm position. And then I'm going to long press the jog wheel, and it will update the switches, the default switch positions, to match my current setup. And now I will not get that switch warning when I turn the radio on again, unless the switch is in the wrong position, in which case I need to put it in the right position. The next thing I want to walk you through doing is setting up telemetry. Telemetry is a little bit of an advanced feature, and not everybody makes use of it, but we have the option to use it, and I think you might find it useful. Here's what telemetry does. Telemetry lets the quadcopter send data back to the controller. Normally, you probably think of the controller as sending information to the quadcopter, like the switch and stick positions, and that's true. But the flight controller can send data back, and that's what telemetry is. What kind of data would it want to send back? A great example of what telemetry can send is your battery voltage. Your battery voltage lets you know when you're about to kill your battery and you need to land and change to a new battery and stop flying. Well, the flight controller has an on-screen display that shows information like that in your goggles, and that's fine, but sometimes it's nice to have that information on the controller as well. Maybe you don't want that information in your goggles. Maybe you want to see it on this screen here. Telemetry is how you can do that. What we're going to do is we're going to go to the Ports tab in Betaflight. On this flight controller, telemetry is on UART 6. What we're going to do is we're going to go over to the telemetry output column on the UART 6 row, and we're going to set that to FreeSky SmartPort telemetry. There's another option, FreeSky telemetry. Don't pick that. We're going to choose SmartPort telemetry, and we're going to say save and reboot. The other option that needs to be enabled for telemetry to work is over here in the configuration tab, and we need to have the telemetry feature enabled, which we did previously. And then here in the radio, I'm going to press the menu key and page till I get to the telemetry screen. And then I'm going to scroll down and highlight Discover New Sensors. And when I hit Discover New Sensors, a whole bunch of new sensors should come in. And this is all data that's being sent from the flight controller. Now, there are several things that this could be good for, but I'm going to give you just one of them right now. What I want you to do is press the menu key and then press the page key until you get to the telemetry screen, and then one more to the display screen. And screen 1, we're going to change to nums, and we're going to highlight one of these dashes, and we're going to change that to one of these telemetry values. And in fact, I can scroll a lot, but the easiest thing to do is to long press the jog wheel, and you'll get a pop-up here. And in that pop-up, you can choose telemetry. And then we can scroll until we find the VFAS sensor. And the VFAS sensor is going to be your battery voltage when you're flying. Having made your screen look just like that, let's hit the exit key. And then if we hold down the page key, we can see our battery voltage and any of the other telemetry values as well. If you find that they're, for example, if you're flying with a GPS unit, you could put your distance home or your max speed in here. These are various things you could do. But this is going to give us a very quick and easy way to check our battery voltage when we're out flying. In fact, let's just take a battery and let's plug it in. And now if I hold down the page key, I can see that I've got a fully charged battery here. Well, that's kind of nice. As long as we're here in the Ports tab, the next thing I want to do is I want to set up SmartAudio. SmartAudio is a misleading name for one of the most important features of your flight controller. On this flight controller, you got a video transmitter right here. The video transmitter sends signal to your goggles. your goggles. It transmits on a certain channel. And if your video transmitter transmits on the same channel as someone else who's also flying, your signals will interrupt each other and you will both crash your quadcopters and be very angry at each other. So being able to move to a certain channel and quickly and easily is the key to harmonious flying with others. SmartAudio also lets you change your output power. Your video transmitter, you'll typically, if you're flying by yourself, you'll have it at maximum output power for maximum range. But then sometimes, like if you go to a race or on some flight events, they'll want you to turn the output power down, and being able to do that quickly and easily with SmartAudio is a really big deal. Now you can do it with these buttons here on the side, but they're kind of a pain in the butt, and SmartAudio is easier. So let's set up SmartAudio. And on this flight controller, the video transmitter is connected to the UART 5, and we're going to go over to the peripherals column, and we're going to enable TBS SmartAudio VTX here in the peripherals column and hit save and reboot. The next thing I want you to do is take a fully charged battery and plug it in. And then I want you to go over to the video transmitter tab, and I want you to see that on the right hand side of the video transmitter tab you have device ready yes, and that confirms that your flight controller and your video transmitter are talking to each other. If you don't have that, there are two main things that could have gone wrong. One of them is that in the ports tab you could have selected the wrong UART number, but that's not the case because I know UART 5 is the right UART for this flight controller. You could also have a problem with the wiring connecting the video transmitter to the flight controller. Hopefully that's not the case either, but if you don't have device ready yes, then probably it's a wiring problem because the configuration hopefully should be correct. The next step in setting up SmartAudio is to load what's called a VTX table. And the VTX table tells the flight controller what channels and output powers your video transmitter supports. Here's how you're going to do that. You're going to click on this link, and that's going to bring up this page on the internet. You're going to scroll down to the TBS SmartAudio 2.0 VTX table. And if you're in the United States, you're going to use the USA table. If you're in the European Union, you're going to use the EU table. And if you're anywhere else in the world, you're probably going to use the USA table. It's just the EU that has a little bit more restrictive guidelines. So I'm going to click on the USA table, and I'm going to see this bunch of nonsense. What I'm going to do is I'm going to click and select the whole thing, all the way from this very first little bracket all the way down to the bottom, and then right click, copy. After that, I'm going to go back to the Betaflight configurator, and I'm going to click the button load from clipboard in the lower right. And that will load this VTX table in. The next thing you're going to do is change the number of power levels from 3 to 4, as you see here. Just increase that to 4, and then change the value and label parameters to match what you see here. So the values should go 0, 1, 2, 3, and the label should go 25, 100, 200, 600. And that's because this video transmitter supports 25 milliwatts, 100 milliwatts, 200, and 600 milliwatts. So at this point, I'm going to verify that SmartAudio is working by changing channels on my video transmitter. And I'm also going to verify that my camera is working, which I haven't done a function check on my camera yet. So now let's try changing channels. We're going to let's change to raceband channel 1, raceband 1, pit mode off. So now it thinks it's on raceband channel 1, and in my goggles, I'm going to go to raceband channel 1, and sure enough, I can see the channel. Now you may have noticed that my video in that last example looked pretty bad. It had a whole bunch of static. It didn't look clear at all. And I want to make sure you know the reason for that in case you run into the same situation. So here's my video transmitter. And this LED that you see blinking here indicates the power level that the video transmitter is at. 25 milliwatts, 200, 400, 600, whatever. It changes color to indicate the power level. And what I want you to notice here is that it is blinking. And if it's blinking, that means the video transmitter is in what's called pit mode. And the idea is that if you are at a race and you are in the pits at the race, you know, like where they work on the quadcopters, and you want to test your video transmitter out, normally you would not power that video transmitter up at all because you could stomp on the signal of somebody else who is racing and cause them to crash out. Well, the idea behind pit mode is that the video transmitter will be in a very, 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 very low power output. And that's why my video looked like crap. It's not at 25 milliwatts. It's at like 0.1 milliwatts. And so if you have terrible range and terrible video, take a look here. And if your LED is blinking, like you see mine blinking here, the way to take the VTX out of pit mode is to long press the power button. And when you do that, when it comes back, it will be solid. Now you should also be able to take the VTX out of pit mode using the SmartAudio menu that I just showed you how to set up. But if that seems to not work or you have any trouble, take a look at this and long press that button to make sure you have a solid LED like you see here and not a blinking LED. As long as we're setting up SmartAudio, there's one more setting I want to make you aware of and suggest that you enable. And that's this option, low power disarm. And I'm going to suggest you set low power disarm to on until first arm. And here's what that's going to do. The video transmitter can get really freaking hot. It is designed to be used in cold airflow from the props while you're flying. It uses that for cooling. And if you are doing what we're doing here on the bench, the video transmitter can get really hot, especially if you've got it set to the maximum possible output power. It's not going to hurt itself, but it just will get uncomfortably hot. And sometimes it'll shut down. So imagine a scenario where you're at a race and you plug in and you set it down and you're waiting to start the race. And while you're sitting there in the hot sun, your video transmitter overheats and then shuts down. Well, the low power disarm will leave the video transmitter at a low output power until the moment when you arm the quad, and then it'll turn the output power up. And low power disarm until first arm basically says the first time you arm the quad, we go to max power or whatever the power is that you've set it to, and then we stay there until you unplug the battery. But at least with this, if you are plugged in on the bench, you're not overheating the video transmitter. The next thing we're going to do is set up our motors. And a major thing that we haven't done to this moment is verify that the motors are spinning the correct direction. The motors have to be spinning the right direction or the quadcopter will not fly. And the direction that the flight controller expects the motors to be spinning is given here in this diagram in the motors tab. So we need to spin the motors one by one and verify that they are going that direction. The way we're going to do that is first we are going to make sure your props are off. Props should be off because I haven't told you to put them on yet, but if your props are on for some reason, take them off. This is not safe to do with props on. We're going to click this button. I understand the risks. Props are removed. And then I'm just going to single click on the master tab. And then I'm going to press the up arrow key on my keyboard and just hold that until the motors begin to spin. And now all of the motors are spinning. Then I need to check the motors one by one and see that they're spinning the right way. And I find doing this with my finger to be a little misleading sometimes. So I like to take like a piece of paper, a business card, a battery strap, and hold it up against the motors one by one. Okay, that is spinning the wrong direction. Motor number 2, the front right motor, is spinning the wrong direction. Motor number 1 is spinning the correct direction. Motor number 3 is spinning the wrong direction. Motor number 4 is spinning the right direction. So for me, motors 2 and 3 are spinning the wrong direction. That is not necessarily true for you, depending on exactly how you soldered up your ESC wires. If you soldered your ESC wires different than me, you may have different motors spinning the wrong direction. You just need to note which motors need to be reversed to spin the other way. The other thing I want to do is I want to check the motor numbers 1, 2, 3, and 4, and make sure that the positions are correct. And they should be, because we installed our flight controller and our ESC facing the correct direction, but let's just double check and make sure that's true. So slider number 1 should be the back right motor. It is. Slider 2 should be the front right. It is. 3 should be the back left. It is. and 4 should be the front left. It is. Okay. That's a check you might want to do. You should do that check on every build. On this build, it didn't turn out to be necessary, but if we were to rotate the ESC or the flight controller, then the motors might need to be remapped. So now I'm going to disconnect my flight controller, and I'm going to go to BLHeliSuite 32, which is the other app that I had you download earlier in this series. I'm going to select my COM port, whichever COM port the flight controller is plugged into, and I'm going to hit connect. When I hit connect, the screen should change to look like this. The connect button will turn into a disconnect button and the COM port will gray out. And then I'm going to hit read setup. And I should get a screen like this. Now I need to reverse motors 2 and 3, and here's how I'm going to do that. Down here at the bottom, I'm going to right click on ESC number 2 to select it and it only. And I'm going to change the motor direction from normal to reversed. Then I'm going to hit right setup. Then I'm going to right click on ESC number 3 and change the motor direction to reversed and right setup. Then I'm going to hit the check button, and that should check all 4 ESCs, and I can verify that ESCs 3 and 2 show motor direction reversed. There are a couple other changes I want you to make here. One of them is I want you to change the PWM frequency from 48 to 24. And I want you to change the motor timing to 23. And then I want you to hit right setup. And the last thing we can do here is go to the ESC overview tab, and we can verify the changes that we've made are in bold. So the PWM frequency has changed to 24. The motor timing has changed to 23 for all 4 of the ESCs, and the 2 ESCs that I previously noted are showing as reversed. The next thing I want to show you how to do is set up your on-screen display. And in order to do that, I've got a screen here which is showing me what the goggles are seeing. I'm going to go to the OSD tab, and this is another case where you have unlimited flexibility to do a whole lot of things, and it can be a little bit overwhelming. But just walk through with me. I'm going to show you a basic setup for the OSD, and then later maybe you can come up with more stuff that you want to put on there. So the 2 OSD elements that I'm going to encourage you to turn on include battery voltage and fly mode. Battery voltage tells you what your battery voltage is. It's how you know when you need to stop flying or you're going to damage your battery. A good rule of thumb is that you should discharge your battery to about 3.6 to 3.7 volts per cell. So for a 4-cell battery, that's going to be, well, you know what? You don't even need to do the math, because there's actually another OSD element, battery average cell voltage, that will show that for you. So I'm going to put these 2 in the upper left-hand corner of the screen, and as I do that, you can actually see them moving around. You can put them wherever you like. You can see them moving around in your goggles as you drag them around. So I need to stop flying when that average cell voltage gets down to about 3.6 to 3.7. If it goes below 3.0, the battery is being irreversibly damaged, and somewhere between about 3.5 and 3.0, it just drops off a cliff. So don't think that stopping at 3.6, you're like, well, what about, could I fly longer? No. Once you get to about 3.5, it just goes, bleh. So stop around 3.6 or 3.7. The fly mode is going to tell you whether you're in angle mode or not, whether you're in auto level mode or not. If you always fly in acro mode, maybe you don't need this, but it can be helpful. It also tells you if you've activated turtle mode. I like to put that like somewhere out of the way because it's going to be there while I'm flying. And then the last thing that's on by default, and you should never turn this off, is the warnings element. This gives valuable troubleshooting information. If your quad is ever having a problem, you're going to need that information. But I am going to encourage you to go over here to the warnings and disable the core temperature warning. I also like to disable the battery not full warning. The battery not full warning warns you if you've plugged in a battery that isn't all the way charged up, but sometimes I do that. I don't need to see a warning for it. And the core temperature warning, some flight controllers run a little bit hot. Betaflight is a little bit too sensitive and will say core temperature too hot. And I just turn it off. It's just don't, you don't need to know about that.